When we look at a galaxy, we see the obvious stuff, right? Stars, gas, and dust, all held together by gravity. But what if there's another force at play, an invisible architect kind of shaping its destiny from behind the scenes? Well, today, we're diving deep into Messier 66, a stunning spiral galaxy in the Leo Triplet, to try and uncover the powerful, unseen forces that really make it tick.
All right, let's get right into it. To really get what's happening in Messier 66, we first have to talk about one of the most fundamental and, honestly, often overlooked forces in the entire cosmos: magnetism.
So we're all taught that gravity is the undisputed king of the cosmos, right? It just pulls everything together. But is that the whole story? I mean, what if there are these giant invisible magnetic structures that are also pushing and pulling, guiding gas, fueling stars, and maybe even recording a galaxy's entire history? Okay, so this is the crucial point. In the absolute vastness of space, there are no giant bar magnets just floating around. As physicist Donald E. Scott reminds us here, cosmic magnetic fields have a very clear cause. It's the flow of electric charge, or what we call electric currents. Where you find one, you're going to find the other. They are literally two sides of the same coin. And this is a perfect way to picture how it works. Just think about our own sun. You have a primary electric current flowing through it, and that can induce these smaller secondary currents right on its surface. Now, those currents generate their own magnetic fields, creating the enormous looping structures that we can actually see. And here's the real kicker. If that main current just changes its strength a little bit, it doesn't even have to reverse. It can cause the magnetic polarity of those loops to completely flip. It's an incredibly elegant and powerful engine. So let's see how this all builds up. We're going to take that very same principle and apply it to an entire galaxy. And our laboratory for this investigation is the magnificent spiral galaxy Messier 66.
To astronomers, it's known as NGC 3627, or sometimes ARP-16. But whatever you call it, this galaxy is a popular target for a reason. It is a place of immense activity, real cosmic drama, which makes it perfect for seeing these invisible forces in action. And yeah, it's not exactly next door. We're talking about a distance of 11 megaparsecs. That's about 36 million light years away, over in the constellation Leo. So you can imagine, we need some seriously powerful tools and some really clever techniques to peel back its layers and see what's actually going on inside. So, why M66? What makes it so special? Well, for starters, it's part of the famous Leo Triplet, a group of galaxies that are all interacting with each other. It's an asymmetric barred spiral, meaning its shape is all distorted. Its internal movements are pretty weird, showing the scars of past gravitational dust-ups. And crucially, there's a massive flow of gas funneling inward, feeding an active, supermassive black hole at its core, what we call a Seyfert 2 nucleus. The whole thing is just a dynamic, evolving system. So the big question is, how in the world do you map something that's invisible? I mean, you can't just take a picture of a magnetic field. Well, astronomers have developed some incredible detective tools to trace their structure across millions and millions of light years. One of the most groundbreaking methods is the velocity gradient technique, or VGT. Now, the slide gives you the textbook definition, but the idea behind it is just brilliant. Imagine a river flowing around some rocks. The water doesn't just go in a straight line. It creates these little swirls and eddies that stretch out in the direction of the current. Well, in a magnetized gas cloud, the same thing happens. The gas motion becomes anisotropic, and that's just a fancy word meaning it's not random. It prefers to swirl in eddies that are elongated right along the magnetic field lines. So, by mapping these tiny differences in the gas's velocity, VGT can effectively trace the invisible shape of the magnetic field. Pretty cool, right? Now, this is where it gets really interesting. Look at this comparison. On the left, you've got the magnetic field mapped out by VGT using CO gas. So that's tracing the cold star-forming regions. On the right, the field is mapped using traditional radio astronomy, which detects something called synchrotron radiation from high-energy electrons spiraling in the field. But look how well they line up. Two totally different methods, tracing two totally different parts of the galaxy, and they reveal this remarkably consistent large-scale magnetic field. This tells us the field is everywhere. It's truly pervasive. Okay, this is fantastic. We can actually see the shape of this invisible field. But that just leads to the next and maybe more important question: what is this magnetic field actually doing? Is it just a passive feature, just kind of sitting there, or is it an active player in the galaxy's evolution? The evidence from M66 strongly suggests it's a powerful engine of change, acting like a kind of cosmic brake.
So, here's how it works. You've got these huge gas clouds, and they're trying to orbit the galaxy's center, just like planets orbiting a star. But the magnetic field, which has parts of it pointing radially inward, acts like a drag force. This magnetic torque effectively robs the gas of its angular momentum, causing it to slow down and spiral inward toward the center. It's an incredibly efficient way to funnel fuel right to the galaxy's core.
And we can see the proof right in the data. This graph is plotting a value called PM, which basically just measures whether the field is more tangential, circling around, or more radial, meaning it's pointing inward. Now watch that blue line from the radio data. As we move from the spiral arms in toward the central bar, boom, it suddenly dives deep into negative territory. That's it. That is the smoking gun, the signature of radial magnetic fields, the magnetic brake, caught in the act of slowing down gas and feeding the galactic center.
But the field isn't just an engine. It also has a memory. It turns out that in the tangled lines of magnetism within M66, we can actually read the story of a violent past collision. Yeah, that's because different ways of looking at it, different tracers, they see the magnetic field at different points in time. So the magnetic field in M66 isn't just a machine shaping the present, it's also a fossil record, preserving the history of ancient cosmic events.
Okay, let's zoom in on the eastern spiral arm. Here, our two views of the magnetic field don't quite agree. So why is that? It's because they're telling two different stories from two different times. The synchrotron view traces these high-energy electrons that have a really short lifespan, so it's mainly showing us the magnetic field as it exists after a recent collision with a dwarf galaxy. But the VGT view, which traces the cold gas, it's revealing a mix of old pre-collision gas and new post-collision flows. That misalignment between them is a footprint of the impact, a preserved echo of a cosmic crash.
So, what does this all mean when we put it all together? Well, it means our view of how galaxies actually work might need a bit of an upgrade. So the crucial point is this. Magnetism is not just sitting there in the background. It is an active and incredibly powerful architect of galactic evolution. By acting as a brake, it transports the raw materials needed for star formation and for growing those supermassive black holes that live at the center of most galaxies. Understanding this helps us refine our models for how all galaxies, maybe even our own Milky Way, came to be. It really is a fundamental piece of the whole cosmic puzzle. And that really brings us to our final thought. M66 has shown us that magnetic fields are a key player in the cosmos, shaping galaxies in ways we're only just beginning to truly understand. It makes you wonder, if this much complex history and activity can be hidden in a single magnetic field, what other profound cosmic secrets are hiding out there, right in plain sight, just waiting for us to find the right way to look?